Hi friends, welcome back. So we started with the salinity of ocean water. We have defined the salinity of an ocean water. We also know that what causes the salinity and what is the composition of an ocean water, right from NaCl to potassium bromide, and the percentage also, as I told you, and I am again telling you, remember them for your examinations. Now coming to the next factors, we started with the factors which affect the salinity and some of the very simple factors, that is evaporation, precipitation and atmospheric pressure. So evaporation positively related, precipitation is inversely proportional. जहाँ ज़्यादा precipitation है, there less is the salinity. Atmospheric pressure, we know that in the areas of high pressure, because of dry conditions, there is a high salinity, and in the areas of low pressure, there is a low salinity because of precipitation and because of rainfall. Then, as I told you, one of the important factor here was the influx of river water. What we studied in this, that wherever the river enters the sea, the salinity is always lesser. Therefore, the salinity is lesser at the mouth of river Ganga, Sundarbans region, in the Krishna Godavari delta, in the Kaveri delta, or anywhere in the world where the major river is entering the sea. Because the Bay of Bengal has more rivers, therefore the salinity of Bay of Bengal is lesser than the salinity of an Arabian Sea. Because there are no major rivers entering the Mediterranean Sea, it is having very high salinity of around 40 parts per thousand. But because the Black Sea has 5 big rivers which enter, which the rivers of Europe, therefore the salinity is below normal. What is the salinity of Black Sea region? It is 18 parts per thousand. The salinity of the Gulf of Bothnia is lesser than the salinity of Baltic Sea region, because of Gulf of Bothnia receives immense volume of or large volume of fresh water through glacier melt and through rivers in those regions. Remember, Finland is known as land of lakes. So numerous freshwater lakes are there in Finland. It is a glaciated topography. Numerous lakes are there, and therefore it is having high water resources and low salinity. Obviously, this water resources drain into the Gulf of Bothnia region. Where is the Gulf of Bothnia located? As I told you, that is your homework. Do that homework very seriously and regularly, and I hope that you have done it. Now, the next factor which we are doing again is an important factor, is the winds. How do the winds affect the salinity? And as usual, we will do some of the regional examples of it. Obviously, the example in which there is a more chance in the examination. Now, how do the winds affect the salinity? If this is a land area, and if this is an ocean water here, in temperature, we have done something onshore and offshore winds. We will use the same concept here. These winds are known as an onshore winds, while these winds are known as an offshore winds. These winds are known as an offshore winds because they are blowing away from the coast. These winds are onshore winds because they blow towards the coast. So these are onshore and these are offshore winds. So how is the salinity affected? Onshore winds, what they will do? Onshore winds, as you already know, they will result into piling up of water. Increase in the level of water because it will result into collection of water. Waves are drawn by the friction of the winds, so it results into piling up of water in this result. Piling up of surface water results into increase of the salinity. So the onshore winds increase the salinity. Increase the salinity increase the salinity, while the offshore winds decrease the salinity. Decrease the salinity. Offshore winds will decrease the salinity. Now coming to this is, I hope that you have understood this. The onshore wind, because it will result into piling up of water, it will increase the salinity. यहाँ पे the offshore winds drives away the water, it removes the water, and as a result it will result into decrease of the salinity on the surface of the ocean water, because the water is removed. Now you tell me, which winds are onshore and which winds are offshore? The trade winds are onshore. The trade winds. The trade winds are onshore. In the tropical latitudes, on which side of the continents? They are onshore on the eastern side of the continents. On the eastern side of the continents. While they are offshore, the trade winds are offshore on the western side of the continents. On the western side of the continents. So the onshore trade winds, as we did in the temperature, the onshore trade winds will increase the temperature on the eastern side of the continents and decrease the temperature on the western side of the continents. We have studied this concept in the temperature. Same concept here. The trade winds, because of their onshore nature in the tropical belt on the eastern side of the continents, they will increase the salinity, while offshore trade winds, where are they offshore? On the western side of the continents, they will decrease the salinity. Now come to the regional example here. If this is USA, if this is USA, what is this region? Open your atlas of this region. This region surrounding this U-shaped region on the eastern side is known as Gulf of Mexico. And this region is known as Gulf of California. Gulf of California. Gulf of California. Now, what does this Gulf of Mexico and the Gulf of California tell about? You tell me the salinity in the Gulf of Mexico versus the Gulf of California region. What will be the salinity? Which region will be having higher salinity? The Gulf of Mexico region or the Gulf of California region? Now, the trade winds, they lie in the trade wind belts. As a result, the trade winds will pile up water on the eastern side of the continents. Therefore, the Gulf of Mexico has, because of the onshore nature of the trade winds, the Gulf of Mexico has an higher salinity. On the other hand, the Gulf of California, the trade winds are offshore. What do you mean by onshore and offshore? That means this is the direction of the trade winds in this belt. So, as a result, they will reduce the salinity on this part. So, what we can write here is, therefore the Gulf of Mexico has higher salinity than the Gulf of California. Than the Gulf of California. Which is the other sea surrounding the Gulf of Mexico region? Open your North American part. See, there is a Gulf of Mexico and the Caribbean Sea region. That means, therefore, Caribbean Sea region, Caribbean Sea and the Gulf of Mexico, has higher salinity than the Gulf of California region. So take this in mind. The second regional example, in fact more than second regional, Bay of Bengal versus Arabian Sea, mouths of rivers, of major rivers, Black Sea versus Caspian Sea versus the Mediterranean Sea, Gulf of Bothnia versus the Baltic Sea, and now Gulf of Mexico versus the Californian Sea. Are you getting? Because it lies in the trade wind belt. The Gulf of Mexico has higher salinity because it lies on the western side. This is where the Gulf of Mexico is lying. This is where the Gulf of Mexico is. And this is where the Gulf of California is. This is where the Gulf of California is. Therefore, if we take this as east and this as a west, therefore the Gulf of Mexico will have higher salinity than the Gulf of California. Therefore, the Caribbean Sea and the Gulf of Mexico has higher salinity than the Gulf of California. Now, taking another example. We have talked about the trade winds. Now, what are the other major winds other than the trade winds? The other major winds other than the trade winds are westerlies. Now, what is the westerlies? Westerlies. These westerlies are onshore on the western side of the continents. These westerlies move. If we look at the map, you know that westerlies move from west to east. So as a result, they will be onshore on the western side of the continents, and they will be offshore on the eastern side of the continent. So what we have to remember is the westerlies are onshore on the western side of the continents, while they are offshore on the eastern side of the continents. Offshore on the eastern side of the continents. And as a result, the westerlies will increase the salinity ले लो या temperature ले लो. It will increase either salinity or temperature on the western side of the continents, and it will decrease the salinity and the temperature on the eastern side of the continents. Now open your atlas and we will see the regional examples. See the Atlantic Ocean region. So this is the North Sea region. This is the North Sea region. And this is the Hudson Bay region. Or this is the Grand Banks region. In the terms of fishings, and this is the Dogger Bank region in the terms of the fishing. And as a result, what is now this all area lies in the westerly wind belt. This is an area which lies in the westerly wind belt. So which will be having higher salinity? The North Sea will be having a higher salinity, or the Hudson Bay, which is near the Canada, near USA, will be having higher salinity? Obviously, this region, that is the North Sea region, will be having an higher salinity. Therefore, because of the wind system, and this we have, earlier part we have written that the higher salinity is there in the Gulf of Mexico versus the Gulf of California. Here you can write is, therefore the North Sea experiences higher salinity as compared to the Grand Banks or the Hudson Bay region. Or the Hudson Bay region. And North Sea experiences a greater salinity as compared to the Grand Banks and the Hudson Bay region. So therefore, this North Sea region will be having a higher salinity. Keep this in mind. imagine where the North Sea is. In the examination, this is how applied questions are being asked. With the change in the pattern, with the increasing dynamism of the examination, this is how the change. And though it is very, very difficult to tell you each and everything through this indirect facility, but will be trying the best to do it. In fact, that is why I am saying that just a month or 2 months before the examination, we will solve many more MCQs, so that you will be very much confident during the examination. But that is, again, I am saying 2 months before the examination. Now the course had got delayed because I was having a serious issue with my health, but the MCQs, it does not make any sense right now. Just 2 months before the examination, I will come with a series of multiple choice questions covering your geography. Now with this here, what you remember here in the trade wind belt, if this is the trade wind belt, in the winds, what you have to remember here, the Gulf of Mexico, has higher salinity than Gulf of California. In the westerly wind belt, North Sea has the higher salinity than the Hudson Bay Grand Banks region. So the first point relates to the trade wind belt. The second point relates to the westerly wind belt. So this is how the winds also affect the salinity. Now, how do the ocean currents affect the salinity? Now, what are these ocean currents? If we take the Atlantic Ocean again, because again it is the best place to study, what are these ocean currents? Ocean current is a circulation of a wind, a circulation of ocean water, or a flow of ocean water similar to a river flow. That means there is an horizontal flow of ocean water when the ocean water flows like a river. So how does it flow? A hot water from the equatorial regions will go and flow, and due to the Coriolis force, it will deflect to the right and it will flow in this region. It will go and flow in this region. This is a hot water which originates in the equatorial regions and it goes towards the polar regions. Again, in the ocean currents, we will understand this, but because I am doing the currents here, because we are doing the salinity here, the factors influencing the salinity, I want to tell you how does it affect. So the hot equatorial water goes from the equatorial regions to the polar regions. It gets deflected and goes to the other part of the continents. What does the Coriolis force say? Any kind of a horizontal movement, including wind or any moving object, will deflect to the right in the northern hemisphere. So it is getting deflected to the right. Now, similarly, cold water, represented by a blue ink. Cold water comes from this region, from the polar region. It mixes with the warm water, and due to the Coriolis force, it comes and settles in the tropical regions. This is how the cold water is coming. So this is how the cold water is coming. Again, Coriolis force, its deflection is to the right. Iska right hand is this. So what you have to remember, even the ocean water, which equatorial ocean water, if it goes to the polar regions, it will affect the salinity. Polar water, if it's coming to the equatorial regions, it is going to affect the salinity. The question is, how will it affect the salinity? I am rubbing this to right here. How will it affect the salinity? Warm, so what you have to remember, warm equatorial waters. Warm equatorial waters, we call them as warm currents. Which is the warm current here, which is shown in the red ink, which is originating in the equatorial regions and going up. Warm currents increase the salinity. in the areas they visit. In the areas they visit. Cold currents decrease the salinity. Decrease the salinity. In the areas they visit. In the areas they visit. So the cold currents and warm currents. Cold, how will they affect the salinity? Warm currents will increase the salinity. Cold currents will decrease the salinity. So this is how the ocean currents will affect the salinity. Now you tell me which part of again an example, which part here will be having a greater salinity. This is an area, Hudson Bay area is an area of a cold current. North Sea, Norwegian area is an area of a warm current. Open this part of an atlas. What is this region? This region is the Labrador Sea region. Sea and Hudson Bay region. And Hudson Bay region. It is this area. What is this area? These two areas? It is the Norwegian Sea and North Sea region. And the North Sea region. And the North Sea region. Now, tell me which part will have higher salinity. Labrador Sea region, Hudson Bay region, or the Norwegian Sea, North Sea region. Obviously, if the warm currents will increase the salinity in the areas they visit, so the warm current is going to which area? In the Norwegian Sea, North Sea region. While the cold current will decrease the salinity in the areas they visit. So the cold current is coming in this region from the polar around the Labrador Sea, Hudson Bay region. Therefore, here what we can write? We can write in this is example is therefore the Norwegian Sea and North Sea region will have higher salinity. Than the Labrador Sea region. Than the Labrador Sea and the Hudson Bay region. So this is how it is. It looks a bit confusing. I will again revise this, what it is. So what we have done, we are doing the factors affecting the salinity. In one of the factor we are doing is the ocean current. What does the factor of the ocean current say? The factor of the ocean current says that warm currents increase the salinity in the areas they visit. So what are these warm currents? Obviously, where will be the warm currents generated? In the equatorial regions, in the tropical regions, jahan pe temperature is more. The cold currents will decrease the salinity in the areas they visit. Where will the cold current generated? In the areas of a cold region, in the polar regions. Now, why they visit? Because currents is the movement of ocean water, just like a river. Therefore, from the polar regions, from the equatorial regions, the current goes to the polar regions. From the polar regions, the current comes to the equatorial regions. Does it go straight? It does not go straight. Why? Because there is a force which we did in climatology, which is known as Coriolis force. So what does this Coriolis force say? The Coriolis force says that any moving object, whether wind, rocket or ocean currents, will be deflected to the right hand side in the northern hemisphere and to the left hand side in the southern hemisphere. Because we are doing because this, for our examination point of view, I am teaching you only, I am giving you an example of a northern hemisphere, because this is an area jahan se UPSC generally focuses, is the Gulf Stream, which originates in this. Instead of going straight, it gets deflected due to the Coriolis force in the right, and it goes into an area which is known as Norwegian Sea, because it surrounds Norway and the North Sea region. The cold Labrador current, instead of coming straight, it gets deflected to the right hand side. Initially it reaches Labrador Sea and Hudson Bay region, and then it reaches the Canary Islands. We are going to do this in the ocean currents. But what we are doing is the regional examples. Therefore, I am saying the Norwegian Sea and the North Sea region, jahan pe the Gulf Stream goes, Norwegian Sea and the North Sea region experiences greater salinity than the Hudson Bay and the Labrador Sea region. So this is a regional example which we are doing. Similar to the examples which we did in the winds, that is Gulf of Mexico versus the Gulf of California. Similar to the examples which we did in the influx of river water, that is the Bay of Bengal versus the Arabian Sea, Black Sea versus the Caspian Sea. So these were the factors affecting the ocean water salinity. At the same time, here we have done numerous seas which are important: Norwegian Sea, Gulf of Bothnia, Baltic Sea, North Sea, Hudson Bay. So out of that, have a proper look at the North Sea region. Remember, it is important for petroleum also. Google and find out what is the petrol deposit which is known in the North Sea region, is it a Brent crude index or Brent crude oil? Is this the Brent crude oil? If yes, then why the name is so? Because this is not the syllabus in my syllabus. I will tell you, in fact, while doing the economic geography also. Then also remember the countries surrounding the Caspian Sea, because this is always in the news, because यहाँ पे बहुत ज़्यादा conflicts are happening. China's one road policy is also that will make it, or India's Connect Central Asia policy will bring that area in the news. What are the countries surrounding the Black Sea? What are the rivers entering the Black Sea region? So this is how the questions will be asked in the preliminary examination, and how the questions will be asked from the things which we have done in the preliminary examination. The questions will be asked in the terms of two statements. They will give you two statements. Consider the following statement: North Sea experiences greater salinity than the Norwegian Sea, than the Labrador Sea. One statement. Second statement: Black Sea has greater salinity than Mediterranean Sea. Than the Mediterranean Sea. Which of the following statements are true? Which of the following statements are true? One, A only. Two, B only. Three, both A and B. 4, neither A nor B. Neither A nor B. So what we have in this lecture and in the previous lecture, in this lecture we have studied the North Sea experiences greater salinity than the Labrador Sea. Why? Because of the effect of an ocean current. So this is a right statement. Now what about the second statement? Black Sea has greater salinity than the Mediterranean Sea. We studied in the previous lecture, no, this is a wrong statement. In fact, remember, Black Sea has a below normal salinity, just 18 parts per thousand. So your answer is, which of the following statements are true? A only. So this is how the questions will be in the examination. So that's why the regional examples are very, very important. Note them down, write them down, and keep on solving the past year question papers. We have finished on the two parts of factors affecting salinity. In the next lecture, we are going to study the distribution of salinity. It is a small topic. And then we'll start with the corals. So till the time we meet again, thank you very much.